we will discuss mirror formula 1 by f is equal to 1 by v plus 1 by u. To derive it, let us consider a concave mirror. If I identify the terms pole, focus, center of curvature, let us suppose any object is kept on the principal axis, P dot A principal axis. We already know all distances are measured from the pole. You have to measure all distances from the pole, these dotted lines. If any light ray incident on the mirror like this, as a result we can able to observe this is as incident ray, O A is a incident ray. We can observe imaginary normal through center of curvature act like a normal. This is normal since all distances are measured from the pole like this. Mirror, light follows laws of reflection. It is the same angle between incident ray and normal. Angle of incident theta we can observe, or I, angle of incident I. It is the same angle, it is taking reflection like this. Suppose I got a reflected ray and incident here. If any light ray moving along the principal axis, there is a possibility from the object one ray can able to move along the principal axis and it retraces its own path. Why? Because along the principal axis angle of incident I 0, reflection also has to be 0. As a result, PO is a reflected ray, and similarly AI is a reflected ray. Here AI PO meet here, point of intersection of reflected rays gives image. So image formed here. We will observe some geometry here. Let us take angle AOP is alpha. Angle AOP is equals to alpha, and this is beta, gamma. Angle ACP is equals to beta, angle AIP is equals to gamma. For our convenience, I will take angle of incident and angle of reflection remains same. Angle I is equal to angle R. I will move with theta. So this is theta. This is also has to be theta. Theta, theta. Now we can able to observe three different triangles. Right angle triangles. OAP is a triangle. CAP is a triangle. IAP is a triangle. Now from triangle OAP, from the triangle OAP, tan alpha is similar to alpha because due to paraxial approximation we can write tan alpha is equal to alpha. Angles are considered to be very small according to paraxial approximation. This is according to paraxial approximation. Tan alpha similar to alpha is equals to opposite by adjacent. Opposite is AP, adjacent is OP. So AP by OP. And similarly tan beta is nothing but beta, CAP from the triangle CAP. This is the triangle CAP. We can observe tan beta, beta is equal to AP by CP. AP by CP. Similarly, from the triangle IAP, observe IAP, tan gamma similar to gamma is equals to AP by IP. We know the distance from pole unto the object distance denoted by letter U, I unto the P, image distance V, C unto the P, radius of curvature R. If you observe the sign convention, all are left side. In the direction of ray propagation, all taken as positive, opposite to this all taken as negative. So if I apply sign convention, AP by OP, AP by OP, OP is U, so we will get minus U. AP by CP for CAP, AP by CP, AP by CP is radius of curvature R, that is also minus R, and AP by IP, AP divided by IP, that is image distance, minus V will come. Now please remember this result. Now from the triangle, OAC, observe the triangle OAC. From this, exterior angle is equal to sum of opposite interior angles. Exterior angle beta, sum of opposite interior angles. Exterior angle theorem, nothing else. So beta is equal to alpha plus theta. Similarly, from the triangle ACI, consider triangle ACI. Exterior angle beta, interior angles, exterior angle gamma, interior angles beta and theta. So gamma is equal to exterior angle beta plus theta, interior angles. Now from this, if I write theta, it becomes beta minus alpha. Now put this theta in this equation. Suppose this is 1, this is 2. Put 1 in 2, where theta is beta minus alpha. So gamma become beta plus theta is beta minus alpha. Beta minus alpha. This become beta plus beta, 2 beta minus alpha. Now gamma is equal to 2 beta minus alpha. We already derived alpha, beta, gamma. Where gamma is, what is gamma? Gamma is AP by minus V. AP by minus V, that equal to 2 beta. 2 into, what is beta? This is beta. AP by minus R. 2 into AP by minus R minus alpha. Alpha is AP by minus U. AP by minus U. Minus of minus plus will come. U. Now do one thing. Take AP common. If I take AP common, what will come? AP get cancelled. Finally, 1 by minus V is equal to 2 by minus R plus 1 by U will come. Can I move 1 by minus V that side? So that 2 by minus R this side, 2 by R become 1 by V plus 1 by U. If you observe the relation between radius of curvature and focal length, R is equal to 2F. This can be written as 1 by F is equal to 2 by R, where 2 by R is nothing but 1 by F. Please observe this result, relation between R and 2F. So finally 2 by R is 1 by F. From this we can write 1 by F is equal to 1 by V plus 1 by U. This is mirror formula, hence we proved. Now we will do one problem. An object is placed at a distance of 30 cm from a concave mirror of focal length 20 cm. So that find image distance and magnification. Solution. Given object distance U is equal to 30 cm, focal length F given 20 cm, we have to find image distance and magnification. If I draw concave mirror, because concave mirror given focal length, okay, we will draw diagram later. Apply mirror formula, 1 by f is equal to 1 by v plus 1 by u. We have to find v. According to this, if I observe sign convention, left side negative, right side positive, focal length taken as negative. Suppose object is here, focal length 20 centimeter given, object is kept 30 centimeter. So 30 means object will be here, O is the object, U, this is negative, F is negative. So U is negative, F is negative. Apply mirror formula, 1 by minus 20 is equal to 1 by V plus 1 by U. U is negative, so U is minus 30, 1 by 30. From this, 1 by V can be written as 1 by minus 20 plus 1 by 30 will come. If I take LCM here, 1 by V is equal to minus 20 into 30 LCM. 20 cancel, 30 will come, minus 30 will come, and 30 20 will come, 20 into 1 20 plus 20 minus 10 by 20 into 30 600. 1 by V become 0 cancel, 1 by 60. So here V is equal to minus 60. Image distance I got minus 60, means image is formed 20, object distance 30, so double image is formed here. This is I. Suppose any object is kept like this, image will be formed inverted manner. So this is image. This distance is 60 centimeter, image distance. Now we have to find magnification. M is equal to, we know the formula, V by U. Magnification M is equal to minus V by U. M is equal to minus V by U. If you apply sign convention, V minus 60, U minus 30, minus minus get cancelled. Now 60 by 30, that equal to minus 2 will come. So magnification is minus 2, means image size is double that of the object. That is the meaning. We will discuss magnification. Magnification M. This is also called lateral magnification. Lateral or transverse magnification. Defined as the ratio of height of the image, and height of the object. To understand this lateral magnification, let us consider a concave mirror. Pole, focus, center of curvature. Any object is kept beyond the center of curvature. If I draw a ray diagram for the situation, if a ray moving parallel to the principal axis, after reflection move through focus. If a ray moving through center of curvature, it move undeviatedly and retraces its own path like this. As a result, I got this edge here. So if you observe, I got image here. To avoid confusion, I will delete these lines. We can use any 4 of the 2 rules. We have 4 rules we already discussed. By using 2 rules, any 2 rules, I got image here. Suppose any light ray incident at pole, it is taking symmetrically opposite direction, angle of incident, angle of reflection remains to be same. Suppose this is angle of incident I, angle of reflection R. I will go with theta, angle of incident and angle of reflection. I got image here. So this is image height of the image H suffix I. height of the object, h suffix o. We can also observe that all distances measured from the pole, this has to be image distance v, this has to be object distance u. Now from the triangles we can observe similar triangles having common base, two triangles, small triangle, big triangle. If you observe from the big triangle, if I write tan theta is equal to opposite height of the object by adjacent is object distance ho by u, and similarly tan theta for the small object, small triangle, height of the image opposite by adjacent is v by v. Since theta remains same, theta remains same, angle of incident and angle of reflection, we can go like this, theta is equal to ho. According to paraxial approximation, you can delete tan, we can go with theta. Finally we can equate these two, so that height of the object by u, that is equal to height of the image by v. Apply sign convention, proper sign convention. Left side v and u taken as negative negative, so this is minus, height of the object above the principal axis taken as positive, below the principal axis taken as negative, height of the image is negative, so this minus get cancelled. So finally this minus get cancelled, so v by u minus v by u become hi by ho. Further, if you observe magnification definition, height of the image by height of the object, so hi by ho is nothing but magnification. Now substitute magnification, m is equal to minus v by u. This is the magnification formula in case of spherical mirrors. Now we will draw ray diagrams in case of concave mirror and for the convex mirror also. Ray diagrams, concave mirror. We will draw 6 diagrams for the concave mirror. So first one, if object is kept at infinity, object is at infinity, concave mirror, pole, focus, center of curvature. Infinity means the parallel beam of light coming towards the mirror. Parallel beam of light indicates that rays are coming from infinity or rays are going to infinity. Minimum 2 rays are required to locate image. Parallel beam of light, I draw 2 rays, parallel beam of light. After reflection, we know the rules. Any 4 of rules you can use, 2 rules. If any ray moving parallel to the principal axis, after reflection it move through focus, reflected ray 1 and again reflected ray 2. As a result, I got image here. If you observe here, if I write characteristics of image characteristics, image is real first thing. Why? Because convergent beam of light converges, actually meet reflected rays, so image is real. Second thing, image is inverted. Yes, it is inverted. Third character, image is forms at focus. Next character, image is highly diminished. Very small size image I got, highly diminished. Image is highly diminished. If you observe, the rays are coming from infinity distance, means object is at infinity, maximum distance, infinity distance, image forms at focus, so that we can say velocity of object is greater than velocity of image. Velocity of image is greater than velocity of object is greater than velocity of image. And what are the uses in this situation? these concave mirrors used as solar furnace. It will be used as solar cookers or solar furnace. Diagram number 1. Next thing, object is beyond center of curvature. Object is beyond C, center of curvature. Pole, focus, center of curvature. Let us imagine candle is object. Minimum 2 rays are required to locate image. If any light ray moving parallel to the principal axis, after reflection, it moves through focus. This way. Minimum 2 rays required. I select this rule. If any light ray move through center of curvature, it retraces its own path. After reflection, it retraces its own path. As a result, we can observe combination of reflected rays. So this edge formed here. If you observe, I got image here like this. We'll draw. This is image. I got here inverted image. Now write characteristics. If I write characteristics, image is first character real, as real, actually emitted rays, reflected rays. Inverted forms between center of curvature and principal focus. Image formed between center of curvature and principal focus. Next, diminished or small size image I got. This is big size, object is big, image is small size image I got. So that character considered to be diminished. Can I say velocity of object is greater than velocity of image? Why? Because object distance is more than image distance. So velocity of object is greater than velocity of image. Next, we will draw third diagram. Object is at the center of curvature. Object is kept at center of curvature. Concave mirror, pole, focus, center of curvature. These are always in equidistance manner. Now object is kept at C, center of curvature. Minimum 2 rays required to locate image. If a ray moving parallel to the principal axis, after reflection it moves through focus, first reflected ray. If I draw this rule, if any ray incident at pole with the same angle, it is taking reflection symmetrically back. So this is reflected ray. So this edge I got here. As a result, we can observe inverted image. This is blue. Okay, object black, blue color image. If I write characteristics, image is real, reflected rays are actually meet, image is real. Inverted, image is inverted. Can I say image size same to that of object? Yes, image size is same to that of object. Same size forms at center of curvature. Where is formed? Image is forms at the center of curvature. Here we can observe velocity of object is equals to velocity of image. Why? Because the distance from pole remains same. Object distance, image distance remains same. So velocity of object is equals to velocity of image. We have to remember another character. If you observe diagram number 1, so magnification considered to be less than 1. Why? Because diminished size. Over here also magnification is less than 1. Why? Because diminished 1. Here magnification is considered to be plus 1 in this situation. Why? Because same size. So magnification is same. Height of the image by height of the object is nothing but same. So magnification is considered to be 1. Now we will draw next diagram. Object is between center of curvature and focus. Pole, focus, center of curvature. Object is here between between center of curvature and focus. Minimum 2 rays required. Any light ray moving parallel to the principal axis. After reflection, it move through focus. Rule number. Okay, I used one rule. Next, I will use any light ray moving through focus. After reflection, it move parallel to the principal axis. So here reflected ray meet here. I got this edge. Image is formed here. I got this edge here, so that image formed here. Yes. Just wait. Pole, focus, center of curvature. Object is between C and F. First ray, incident ray, move through focus. If any light ray moving through focus after reflection, it is moving parallel to the principal axis. I got this edge here, so image is formed here. If you observe, image is magnified image I got. If I write characteristics, image is real. Yes, actually meted. Reflected rays are met actually. Image is real. Inverted, magnified, or enlarged. Size is big. Velocity of object is less than velocity of image. Object distance less than image distance. So velocity of object is less than velocity of image. If you observe here, magnification is greater than 1. Why? Because big size, magnification is greater than 1. Or you can consider magnification m is equal to 2. Magnification m is 2, you can consider. Height of the image by height of the object, you will get minus 2 here, sign. Fifth diagram. Now object is kept at focus. Object is at focus. Pole, focus, center of curvature. This is object. Minimum 2 rays are required to locate image. If a ray moving parallel to the principal axis, after reflection, it move through focus. I draw first ray. If any light ray incident at pole, reflected symmetrically back opposite direction. So this is second one. If you observe, these two rays are moving parallel manner. I try to extend this backward, even though I do not get any intersecting point, so that these two rays are moving at infinity distance, moving to infinity distance. So if I write characters for these situations, characteristics, for the image. Image is real image, S real image. Inverted should be inverted only. Magnified image, magnified only. And form set, image is going to formed at infinity distance. You have to remember one thing. Whenever object is at infinity, first diagram, image forms at focus. Now object is at F, focus. Image is going to be forms at infinity distance. So here velocity of object is lesser than velocity of image. We can also observe here magnification is greater than 1, obviously. Now we will draw last diagram in case of concave mirrors. Sixth diagram, last one. Object is kept between focus and pole. This is very important one. Pole, focus, center of curvature. Object is kept between focus and pole. Minimum 2 rays required. Any light ray moving parallel to principal axis, after reflection it moves through focus. This is one ray. I will use the rule to draw second reflected ray. If any light ray incident at a pole, it is reflected symmetrically backward. So this is second reflected ray. If you observe, these two rays are divergent beam of light rays. They are not going to meet in front of the mirror. If I extend these rays backward, there is a intersecting point. Means image is formed here. Image. If I write the characters, image is virtual image. Divergent beam of light gives always virtual image. Image is virtual and erect. Image is virtual, erect. Erect means upright. Real images are inverted. Virtual images are upright, erect. As usual, this is object, this is image, upright. So no inversion takes place. And forms where forms inside the mirror, far away inside the mirror, forms inside the mirror. So here we cannot able to measure distance. Virtual images we do not able to catch on the screen. So that distance, velocity of image object I cannot able to compare here. Why? Because virtual images cannot able to caught on the screen. Very important. And if you observe, magnification is +2. Actually magnification is greater than 1. So approximately I treat +2, double size. So magnifying image I got here. So another character you can write enlarged or magnified virtual image. If you observe in this situation, these mirrors used as makeup mirrors and shaving mirrors. Whenever the artist face is between P and F, the face has to be zoomed. So that used as makeup mirrors and shaving mirrors. And in other uses of concave mirrors, we can observe it is used in automobiles, headlights, and concave mirrors are used in telescopes. Next we will draw ray diagram for the convex mirror. We can able to draw only two diagrams in case of convex mirror. Suppose I take a convex mirror, pole, focus, center of curvature. If the object is at infinity, object is at infinity, then if the object is at infinity, then rays are coming, parallel beam of light indicates that rays are coming from infinity distance. If a ray moving parallel to the principal axis, after reflection, in case of convex mirror, these rays are appear to moving from focus, or these rays are looking like emanating from the focus. Reflected ray, divergent beam of light gives virtual images. So that point size image is formed here. Ferrite characteristics image is virtual image, and upright or erect image we will get forms at focus. Image is formed at focus. We cannot able to catch these images on the screen. So these are the characteristics. And another character, highly diminished image. Highly diminished image is highly diminished. Next we will draw a next diagram. Last diagram. For the convex mirrors only you can able to draw two diagrams. Convex mirror, pole, focus, center of curvature. Object is between infinity and pole, between pole and infinity. Suppose I kept object here. Minimum 2 rays are required to locate image. If any ray moving parallel to principal axis, after reflection looking like emanating from the focus, minimum 2 rays required. If I draw a ray, any incident ray, incident at pole, reflection takes place symmetrically opposite direction. If I extend this reflected ray, I got this tip here. As a result, image formed here. This is image I. If you observe, image is diminished. First of all, if I write characteristics, image is virtual, diminished. Image is virtual, diminished. Third character, forms between pole and focus. Understand? Image is virtual and erect or upright. Erect or upright. If you want to draw, for this case, if you kept any way in front of the mirror object, here, always you will get image between pole and focus. No doubt. And what are the uses about these convex mirrors? If I telling you uses, convex mirrors used as floodlight reflectors, and in ATM missions, whenever you went to ATM missions, you will observe a mirror. Those mirrors are convex mirrors, and convex mirrors are used. If there are short turnings, suppose this is one way, this is another way. This is very short turn. So one vehicle moving this way, another vehicle moving this way. There is a possibility collisions takes place. These two vehicles, nothing but accident takes place. So to avoid this kind of incidents, there is a convex mirror fixed, so that this fellow can able to observe the vehicles in the mirror. So these are used as convex mirrors are used at commercial places and sharp turnings also, and convex mirrors used as rear view mirrors for the vehicles. These are the uses of convex mirrors.